So in today's video, we're going to start looking at Chapter 11. Chapter 11 and Chapter 12 are all about hypothesis testing. And the point of hypothesis testing is basically to make decisions based on data that we have. And what we're going to be doing is something called tests of significance. Okay. A test of significance is where we test out a hypothesis, where we test out whether we think something is true or not. And we will do this with a particular significance level, a particular almost like confidence level, as we'll look at in a minute. Okay. So in this kind of test, in a test of significance, we are always trying to test a hypothesis, but we are trying to test something called a null hypothesis. There will be two different types of hypothesis. There will be a null hypothesis and an alternative hypothesis. And the purpose of one of these significance tests is to test whether the null hypothesis is true. And if it is not, then we're going to reject it in favour of that alternative hypothesis. So we will either like what we see with the data when we test this thing out, and we'll say, okay, let's go with the null hypothesis. But if for some reason it isn't correct based on the data that we have, we say, okay, we're going to reject that null hypothesis in favour for this alternative hypothesis that we've come up with. Okay? Just as a quick piece of notation, the null hypothesis is always denoted by H with a subscript of 0. The alternative hypothesis, depending on which book you read, it can be written in different ways. It's normally written as either H with a subscript of A or H with a subscript of 1, depending on the book that you read. So as I said, we always presume that this null hypothesis is true. So we always presume true. Unless we have some kind of overwhelming evidence in favour of that alternative hypothesis. Okay. So the kind of hypotheses that we look at tend to be something to do with statistics. We normally have hypotheses that are trying to hypothesize something about the mean of a population or the population proportion. So you're normally going to have a null hypothesis that would say, well, I think that mu, the population mean, is equal to this value. But my alternative hypothesis would be, okay, well, I don't think it is that particular mean. I'm going to say that it's something else, whether that be greater than the mean that I just stated, less than that mean, or just not equal to that mean. So a classic example is something like where you would have the null hypothesis would be, well, I think that the mean, I don't know, maybe 5. And that's what our initial guess was. But then someone may come along with some data and say, hang on a minute, I just tested this thing out. And I think that that mean is actually greater than 5. So your alternative hypothesis would be mu is greater than 5. So you assume that that null hypothesis is true because that's what you've thought all along. But then you're going to conduct one of these tests of significance and say, okay, let's see if that is actually true or not. And if it's not true, and if we have overwhelming evidence against the fact that this mean is 5, we'll go with what this other person found and we'll go with that alternative hypothesis instead. Okay, so we always assume that that null hypothesis is true until proven otherwise. Okay. There is a video on the Blackboard page. It's one of the Against All Odds videos that we used to watch in class. It's video number 25, and it discusses the null and alternative hypothesis. So if you go under videos on the Blackboard page, it should be there under video number 25, and it will discuss more of this stuff if you would like somewhere else to look as well. In this example, it says that a molecular biologist has been investigating several species of wild potato plants and believes she has discovered genetic properties that will increase the yield of the standard species. She has genetically engineered these new properties into the standard variety and produced a new variety. The standard species yields an average of 2.34 pounds per plant, and she would like to know if her new plant has a superior yield. Okay, so the standard species that she's had all along had a mean of 2.34. Okay, that was the average yield. She's going to stick with that unless proven otherwise. So she's modified this thing in some way, but she's going to say, okay, I'm going to assume to start with that this thing still has a mean of 2.34, but I would like to know if it has a superior yield. So I'm going to see if I can prove that the mean being 2.34 is incorrect, and if instead it is actually greater. So my alternative hypothesis is that the mean is greater than 2.34 pounds. Okay. Make sure that you get these the right way around. Whenever you do this, your null hypothesis should always have equality. Okay. You should always have that the mean is equal to something or the population proportion is equal to something. You should never have a greater than, less than, not equal to, or anything in that null hypothesis. It should always be an equal sign. Okay. You're going to assume that it's the same as it was before unless proven otherwise. Then the problem will tell you whether that they think from some other data that they found that it's actually greater than, less than, or not equal to. Okay, so make sure you always get this the right way around. If you had switched these two hypotheses and instead said that your null hypothesis was that the mean was greater than 2.34 pounds, you wouldn't have anything to prove because you assume that that null hypothesis is true from the start. So if you're assuming that it has superior yield, you've got nothing to prove. So make sure you always start with that null hypothesis is that it stayed the same, and then you can prove otherwise. As we've seen here, we have a greater than in our alternative hypothesis. That's not always the case. As I said, you can have a greater than, a less than, or you can have a not equals. These different types of hypotheses have a name. So let's come back here. If you have a one-sided alternative hypothesis, okay, that means that you've got that the mean is greater than or less than, or that the population proportion is greater than or less than, okay? So you will always have something with a greater than or less than in the alternative hypothesis. So it would be something like H of A, I'll put EG here, that the alternative hypothesis is that the mean is, like we just saw, greater than 2.34. You could have, if you were dealing with something in proportions, you could have that the population proportion is less than, I don't know, 0.16. Okay, if that's what the problem was looking at, if it said that we think that the population proportion might be less than 16%, let's see if our null hypothesis is true or if this alternative is true. Okay, so whenever you have a greater than or less than, it's always a one-sided alternative. A two-sided alternative hypothesis is slightly different. Okay. Whenever you have a two-sided alternative hypothesis, that means that you have to look at both greater than or less than. So anything that is not equal to what is in that null hypothesis. Okay. So if we go back to our example that we had here, okay, we had that we said from the start that the mean was 2.34 pounds. If instead she has done this, but she just wanted to change the yield rather than increase it, so she didn't care whether it increased or decreased the yield, and she just said that she would like to know if her new plant changes the yield, then that would mean that we would have a does not equal, okay, because it could be greater than or it could be less than that mean of 2.34, okay? So if it just says that we think it's different than that mean, then it's a two-sided alternative. So a two-sided alternative hypothesis is just anything that has a not equals in it. So you'd have something like the alternative hypothesis would be that the mean doesn't equal 2.34. Or if you're dealing with something with proportions, it could be does not equal 0.16. Okay. Now, when we look at these tests of significance, there's two types of error that you have to be aware of. Don't worry about this too much. It will come up at some stage in 11.2, but you don't really have to worry too much about the meaning of it, really. It's two types of error. There is a type 1 error and a type 2 error. We'll start with the type 1 error. What this tells you is it's the probability, okay, that you will reject H0 when in fact it was correct, okay? So a type 1 error, it has a probability, we'll call it alpha, that you will reject the null hypothesis when in fact it was correct. So type 1 error is where you've said, okay, from the data that we have now seen, this new data that has come in, we're actually going to reject our null hypothesis in favour of the alternative. If that was actually the wrong decision, then that thing is a type 1 error and it has a probability of alpha of happening. Okay, that alpha is called the significance level of the test. And we will come across that in 11.2. So the probability that you will actually have a type 1 error is alpha. Okay, and the type 1 error is when you reject the null hypothesis in favour of the alternative when you weren't supposed to, when the data didn't actually state that that was what was supposed to happen. Okay, a type 2 error is the opposite of this. Type 2 error is when you fail to reject the null hypothesis when you should have done. Okay, so when you actually fail to reject H0 in favour of the alternative, but the alternative hypothesis was actually the true one. Okay, so a type 2 error is when you fail to reject the null hypothesis H0 in favour of the alternative hypothesis when in fact the alternative hypothesis was true. Okay. So if you reject the null hypothesis when you shouldn't have done, that's a type 1 error. When you fail to reject the null hypothesis when you should have done, that's a type 2 error. Okay. The other thing to be aware of is the steps that you go through when you conduct one of these hypothesis tests. So right now, all we are actually looking at is step 1, and that is to get our null and alternative hypotheses and to write them down clearly. Okay, I will go through an example of this so you can see how it all works. But what we focused on right now is step 1. Okay, the others will come along like in 11.2 as we go through the different sections in 11.2. And you will actually see how to conduct one of these full hypothesis tests. So let's go through this. So steps to conduct a hypothesis test. Okay. Step 1 is just to determine the null and alternative hypotheses. So you're just going to write down what your null hypothesis is and what your alternative hypothesis is. And it will always be in terms of a mean or a proportion for what we are doing right now. Okay? Everything's going to be in terms of means and proportions. So that's the first step, and that's what your homework is going to focus on as well for 11.1. Step 2 is actually easy to pick out from the problem, but again, we will do this in 11.2, and that is to specify the significance level. Okay. So in the problem, they will give you a significance level, and remember, that is the probability of having a type 1 error. So that is the probability that you will actually reject the null hypothesis in favor of the alternative hypothesis when you weren't supposed to. Okay, but they will give you that in the problem. So you always write that down. Step 3 is to look for a test statistic and to compute its value. Again, we will look at these in 11.2, so don't worry about it right now. But I want you to see as you go through 11.2, you can kind of check these off so that you know as you go through one of these hypothesis tests exactly what you're supposed to do. So identify the appropriate test statistic and compute its value. Step 4 is to make a decision as to whether you're going to reject or fail to reject that null hypothesis. And that will be depending on what that test statistic is. And then step 5 is just stating the conclusion in terms of the original problem. So you will have done all of this mathematical work, but once you have done that, I want you to state the answer in terms of the original problem. So you can state, okay, I have rejected the null hypothesis, which means that I reject the fact that my mean is this value, or I reject the fact that my population proportion is this value. So you always pull it back to what your initial problem was at the start. So step 5 is to state the conclusion in terms of the original problem. Okay. So as I said, in this section 11.1, we are focusing on this first step here to determine what the null and alternative hypotheses are, and then we can go ahead and do a test of significance, and we will do that in 11.2. But I really want to make sure that we get this null and alternative hypothesis down. Make sure that you know exactly what you are trying to prove when we go ahead and do that in 11.2, because if you don't know what you're trying to prove, it's very difficult to do the problem. So make sure that you know exactly how to define the null and alternative hypotheses. I'm going to look at a couple of examples that come from your homework. This one is a mean problem. Okay, so it says a manufacturer of potato chips would like to know whether its bag filling machine works correctly at the 417 gram setting. Is there sufficient evidence at the 0.02 level that the bags are underfilled? Now, a lot of this problem right now may seem very weird and we don't know how to solve it yet, but what we need to do here is to state the null and alternative hypotheses for the above scenario. So it's not asking you to solve anything yet. We're going to discuss that in 11.2, but you need to be able to look at this and give me the null and alternative hypotheses. Okay. So it says that they want to know whether the machine is working correctly at the 417 gram setting. Now we're going to assume that that is exactly what the machine was set up to do. We're going to assume that it is working correctly and nothing to the contrary is happening. So we're just going to say that our mean is 417 grams. That is our null hypothesis. What we are trying to prove is whether the bags are underfilled. So your alternative hypothesis would be that the mean is less than 417 grams, because they are saying whether there is sufficient evidence that the bags are underfilled. If they had said that the bags were overfilled, we would be looking at the mean being greater than 417. And if they said whether the bags were just not the mean, that they weren't filled to the amount that we thought that they would be, then it would be a not equals to. Okay, so for this problem here, our null hypothesis would be written as the mean is equal to 417, and our alternative hypothesis is that the mean is less than 417. Okay. When you do this, Hawks will ask you to actually write in whether you are doing the mean or the population proportion, so whether you're doing mu or p. If you need to write mu because it's not on a standard keyboard, there is on the right here, you see that button that says keypad? That will come up each time you do a problem. So on the right, if you click that keypad button, it will come up with a keypad, and mu is one of the options. So if you ever need to type in that the mean mu is equal to something, mu is on that keypad on Hawks. Same with a not equals to symbol. If you ended up with a two-sided alternative hypothesis and you need to do a not equals to sign, that is also on the keypad. For population proportion, you just use the letter P. There's nothing special on a keypad for it. And same with greater than or less than, you can use your standard keyboard for it, but use that keypad on Hawks if you need the mean, mu, or if you need a not equals to sign. They have them there. This is another problem here, which is looking at a proportion. So it says that the mayor of a town has proposed a plan for the construction of an adjoining community. A political study took a sample of 1,000 voters in the town and found that 56% of the residents favoured construction. Under the data, or using the data, a political strategist wants to test the claim that the percentage of residents who favour construction is over 52%. So that's what he wants to test. So he's gotten this new data in from these 1,000 voters, and it's greater than what he initially thought it would be. So his null hypothesis was that he thought it was going to be 52%. That's where he was at. But he got this new data from the 1,000 voters that suggested it was 56%. It was greater than the 52%. So he wants to know if his population proportion is in fact greater than 52%. So if we come back to here, for this one, your null hypothesis, he originally thought that it was going to be 52%. But from these 1,000 voters, he found that the proportion was actually 56%. So his alternative, he thought it was greater than. Always look at the wording of the problem and read the problem carefully. He said in this problem, he wants to test the claim that the percentage of residents who favour construction is over 52%. He's not looking at whether it's different than 52. He wants to know if it's actually over 52. If it was different, you'd use a not equals to, over use a greater than, and under use a less than. Okay, so make sure you actually read the problem. Okay, so he wants to know if the population proportion is actually greater than 52%. And this is what he's trying to prove, but he's going to assume this until proven otherwise. Okay. All of the problems in 11.1 are very much like this, so try them out and see how you get on. And if you have any questions, please feel free to ask me and I will be happy to help. And I will see you in the next video.